Hi everyone, welcome to another episode of the Cabinet Vision Guy. In today's episode, we're going to continue our series on JavaScript, and we're going to finish out our series of episodes on JavaScript variables, Cabinet Vision parameters, and CV attributes. Specifically, today we're going to take a look at some best practices when we're reading Cabinet Vision parameters, and we're also going to take a look at how we can change the styles of those parameters to become attributes and notes as well. So just a slight recap, in the last episode we added a simple parameter to assembly level, and that's a text parameter, and we added an alert as well using this .getParameterValue. And in this episode what we're going to do is we're going to look at how we can read those parameters using the different methods available inside CV and where we'd go about using those. So I'm just going to start by uncommenting this section here, and in here what we've got is a conditional statement. And what we're doing is we're just checking to see if our parameter exists. And to do that, we're using this .hasParameter. And this is the fastest way to check if our parameter exists. Sometimes what we'll see is this .getParameterValue and checking if that is null or not, when in reality all we need to do is just use this .hasParameter, and then we can include some code in here. So this is the one that I'd be using if I'm just going to check if this exists or not before I create the parameter itself. And again, this is the fastest way to check if a parameter exists or not. So in your UCSs, it's worth having a look through to see if you're using this .getParameterValue or this .evaluate to check and swapping them out to this one. Next, we can include a conditional statement if we do care what the value of our parameter is. So if I come up to the top here, what we can do is use this .getParameterValue. And just like with a JavaScript variable, we can use a conditional operator in here to check that the value is a certain value or doesn't equal a certain value, etc, etc. And this is a really common thing to see where we're calling getParameter multiple times in one if-else-if block of code. So we're using it to check my text parameter value 1, my text parameter value 2, or my text parameter value 3. And again, this is really common to see in a UCS. So what we're actually doing is we're getting the parameter value 3 times in this instance. So another way of doing this, and a faster way of doing this, is storing the parameter as a JavaScript variable and then using that in our if statement instead. So instead of doing this .getParameterValue 3 times, we're only doing that once, and then we're using the JavaScript variable to check against in our if statement. Now, a slight improvement on this again would be to use what we call a switch statement. So rather than saying if something equals or doesn't equal true in an if-else-if block where we're always going to be moving through this code, what we can do is we can choose to switch our JavaScript variable, and in each particular case we can execute some code and do something, and then we can choose to break at that point and exit out of our block. So it's a little bit quicker again when we're working through multiple different options. What we have to bear in mind is we might be running upwards of 20 or 30 UCSs, and just knowing which method to use for what and when to use things like hasParameter versus getParameter, and when we should be reading things in as a variable and reusing that can really help us build up an optimized system. So as well as being able to get a parameter value and check it if it exists, we can also pass something to a parameter to be evaluated. So if I uncomment this section down here, and to do that we can use this .evaluate. So what I'm doing with this for my evaluated p-value is I'm setting this to this .evaluate, and at this point I'm actually passing a text variable to it, and I'm saying dy plus dx plus dz. And I'm using obviously the length, width and thickness of the assembly, but if I wanted to take the parent, I could simply pass it the parent value as well. So this will accept normal Cabinet Vision equations. We could also use a parameter that we're setting above when we're using this .evaluate when we're reading parameters. So if I just copy some code in, and I'm going to be really lazy and I'm going to steal some code from where I'm setting the parameter up here. And I'm just going to change this to a measurement. So what we could do is we could choose to add this in here, and the value that is going to be read back is obviously going to be the dy plus the dx plus the dz plus our parameter that's being set up here. Now the same is true when we're actually setting parameters, so we can use this dot evaluate as well. So what I'm going to do is I'll just take that out of there for a second, and I'm going to copy this into here, and I'm going to put this in quotation marks. So we're going to take a look at this parameter on cabinet level, and you can see at the moment I've got this set to be in the dy plus the dx plus the dz. So if I just close this down and take a look at my measurement, you'll see that this evaluates down here, and again we can see that the dy is added onto the dx plus the dz. So if we now just change this over to this dot evaluate instead, rather than letting it evaluate once the parameter has been applied, we should see that we can no longer see the calculation because this is now being evaluated in our UCS. So as well as being able to evaluate intelligence, we can also use evaluate condition as well. So I'll just come down here. So we might want to build in some intelligence and return a true or false bool if something, for instance, about our assembly is true. So in this example, we're checking if the dx is above 75 inches. And if this is true, it's going to return true for us, and then we can check that again as a JavaScript variable, but we can check that and include that in any conditional statements, and obviously run some code if that is true or false. Before we get onto attributes, notes, and choice lists, I just want to highlight again the importance of knowing how to optimize JavaScript variables and when to use getParameter versus evaluate versus hasParameter. And to do that, I've prepared a little test for us, and this is just our UCS below, and I'm going to enable this and just take a look at the code. So what our UCS is doing is it's running 4 individual loops, and the loop size is pretty ridiculous. It is 99,999. And in each individual one, what we're doing is we're either using hasParameter, getParameter, evaluate, or a JavaScript variable. So in our first loop, what we're doing is we're just looping through our ridiculous loop count. And each time we're checking if this has parameter, and we're using cabno, so that will exist obviously for the assembly. And all we're doing is we're including that in a conditional statement. So we're using if this dot has parameter, and if it does, we're just increasing our number by 1. And in the second loop, we're doing the exact same thing, except we're using get parameter value. And in the third loop, we're using evaluate. Now in the fourth loop, what we're doing is we're just capturing the cabinet number outside of the loop itself, and then we're using that to check against. So we're using a JavaScript variable for the last one down here. Now, this test is not designed to simulate any real-life scenario inside Cabinet Vision. We shouldn't have a UCS that runs on 99,999 parts. If you do have a UCS that runs on that number of parts, please feel free to email it to me and I'll help you rewrite it into something a little bit more sensible. The reason we've gone for such a ridiculous number is just to show the time difference, because if not, it would be sort of microscopic. So what I'm going to do is I'm going to return down to cabinet level, and I've got this wrapped up in a attribute to allow me to toggle this on the left hand side. And when each function runs, what it's going to do is it's just going to capture the time difference and produce me an alert message and let me know what's happening. So my first run with hasParameter has taken 1.86 seconds. GetParameter value is a little bit longer, that's 1.941 seconds. And evaluate should be the last one, it takes the longest, is what we'd expect, and this is 2.36 seconds. So again, all the different functions do have a little bit of difference in time. hasParameter and just checking whether the parameter exists is the fastest one. Then getParameter value, and then evaluate, which is obviously something we can pass values to evaluate to, being the slowest of the 3. And the last one is the use of a JavaScript variable. And this one is a lot quicker because we're not making any calls within our UCS. We're handling that completely outside of our loop, and our loop is just checking our JavaScript variable. So again, it's really important to make sure that we've got our UCSs optimized. We're using hasParameter, getParameter value, and evaluate correctly. And wherever possible, we're using JavaScript variables throughout our logic and conditional statements. The last thing that we're going to look at today, if I just head back up to my UCS, and we'll turn this one off, is attributes, notes, and choice lists. So if I head down to the bottom here. So as well as being able to set and remove a parameter, we can also choose to modify a parameter. And to do that, we use this .modify parameter, and we provide it a parameter name, we provide it a modification type, and then we provide it a value. So you'll see on this one, what I'm doing is I'm using this .set parameter, and I'm setting an integer. And then what I'm doing is I'm using this .modify parameter. I'm choosing to modify the type of parameter, and I'm choosing to modify it from an integer to a measurement. Now, as well as being able to modify the type, we can also modify the style. And again, this is where our attributes and notes and our choice list come into play. So what we've got down here is we've got a little bit of code that's going to set up some attributes for us. So parameters exist when we look in the object tree, but attributes will exist on the left-hand side whenever we select the object. So if we're applying this to cabinet level, that's going to appear on the left-hand side and allow us to input something or choose something. And if we're applying this UCS to part level, that's also going to allow us some control over there to be able to set our attribute. So to create my attribute, what I'm doing is, firstly, I'm checking whether it exists or not using has parameter. I'm then setting the parameter itself using obviously the same name. I'm setting the value as a measurement, and I'm just inputting 10 inches into this. And then what I'm doing is I'm using this .modify parameter. I'm then modifying the style. I'm setting the style to be an attribute. And then the last modification that I'm doing is the other modification that we can make, and that's to modify the description. And then this is the description that will appear on the left-hand side on assembly level for me. So what I'm going to do is I'm just going to return out of this and take a look, and you can see on the left hand side I've got my option there to input a value which can then be used throughout the rest of my UCS. If I just head back into my UCS. Now, just like with a parameter, what we can do with this is we can read the value back into a JavaScript variable to be used throughout the rest of the UCS. So again, it's very handy and we can optimize our code. You'll notice in several other videos that I've got, we'll tend to put this behind a function into a library, so we don't have to worry about that. And all we have to do is call a function to set up an attribute for us. Now, to create a note is very similar. The only real difference is we're changing the style from an attribute to a note. We need to provide a description, and we also need to provide a value for it as well, and a type. But if we just return down and take a look at this one. So to get to my note, I'm going to go into properties and into notes, and we should see our new note there as well. So the last option that we need to look at is the ability to create a choice list. And if I just head back to my UCS, and right down at the bottom, take this out. So just like with a parameter, we can change the style of it to become an attribute. We have a slightly different method to use when we're creating a choice list. So instead of using this .set parameter, what we do is we use this .create choice list, and then we pass it a attribute name. We pass it the value, which for us is obviously going to be a choice list. So we've got none, option 1 equals 1, option 2 equals 2, and then obviously option 3 equals 3. The type for this is an integer. And again, we're going to do modify parameter, and we're going to change it to an attribute. And then we're also going to change the description as well. And I'm going to input a description. And if we just return out of this, I'm actually going to comment out the last line of code there for a second. What I should now have is, if I click on my assembly, I've now got my choice list and my different options available. If I just select one of these options and take a look under parameters, you'll see that my choice list is now set to being a value of 3. So there is one last thing that we want to look at when we're working with choice lists, and that is we might want to set a default value on that choice list. So initially, when we're creating our choice list, what it's going to do is it's going to set the default value to none, because that's the first one on our list. So what we might want to do is set it to be an option number 2, for instance, by default, and in which case we can use this .set choice value, and again we're passing it the attribute name that we're working with, and then we're passing it the default value, and then this should set our default value when it's created. Now what I'm going to do is I'm just going to move this out of our if statement, because we're actually checking if this exists before we're setting it. And this will now actually hard code and force us to always have the option 2. Now there's one last difference to mention on parameters versus attributes and notes. If I have a UCS that applies to cabinet level and sets a parameter, and I disable that UCS, I would expect that parameter to still be there if I'm applying it to cabinet level. If I have a similar UCS that's applying to parts and it sets a parameter, I wouldn't expect that parameter to exist if I disable the UCS. Now it is a little bit different for attributes and notes. These will still exist on assembly and part level as well, so it's just worth being aware of. Obviously with an attribute and a note, we do want that to exist because it's allowing us to set something and have some user input, so we need to check if it exists. Hopefully you found this episode and the last couple of episodes useful. Feel free to give us a like, share and subscribe. We're on Facebook, that's facebook.com/thecabinetvisionguy, and Instagram too, that's instagram.com/thecabinetvisionguy. Cheers!